On April 13th, ESA will launch the Jupiter Icey Moon Explorer spacecraft from French Guiana. But what is this mission trying to achieve?
Well, to help us find out more, we're talking to Professor Michele Dougherty, the principal investigator for the magnetometer on board the spacecraft.
Please leave us a review on your podcast platform or send us a message on our social media pages at Space and Things 1 on Twitter and at Space and Things Podcast on Instagram and Facebook, or via the contact form on our website.
And do us a favor and consider joining us over on Patreon. That's patreon.com/Space and Things. But right now, enjoy episode 137 of the Space and Things podcast.
Oh my God! Unbelievable, but isn't it great this time?
You're listening to the Space and Things podcast with Emily Carney and Dave Giles.
I'm Emily Carney.
And I'm Dave Giles. And welcome to episode 137 of the Space and Things podcast. And it actually is 137 this week. Emily, I don't know if you noticed, but last week I said episode 137 instead of 136.
Oh no, I did not notice. I apologize. Oh my gosh.
I had all of two people message me about it, so I'm sorry about that mistake. We've been recording a lot of episodes in advance, or a lot of interviews in advance, so it's been getting a little bit confusing to what episode we're actually recording when we're sitting down.
Yeah, we have been doing a lot in advance, and we've been pretty busy, but we've got a lot of cool interviews, which is really awesome.
Yes, we have. Anyway, how you doing, Emily?
I'm doing good. How about you? How you doing?
Yeah, not too bad over here. Not too bad. All right, so should we get started with this week's main feature then?
Yes, let's go.
Okay, assuming all things go as planned, which we all know isn't very often in the world of spaceflight, but assuming they do, the European Space Agency are launching the Jupiter Icey Moon Explorer, which has delivered us the tasty acronym JUICE. It's delivering this spacecraft on an Ariane 5 rocket from French Guiana on the day this podcast comes out, the 13th of April.
So we thought it would be a good idea to learn more about what JUICE is setting out to try and achieve. So we talked to our friends at ESA, and they said we should talk to Michele Dougherty, the principal investigator for the magnetometer aboard the spacecraft.
So JUICE will spend at least 3 years observing 3 moons of Jupiter, Ganymede, Callisto, and Europa, which were discovered to all show signs of hosting liquid water oceans when explored by the Galileo spacecraft and later by the Cassini spacecraft when it was en route to Saturn.
Professor Dougherty is the head of the physics department and Royal Society research professor at Imperial College London. She was principal investigator for the Cassini spacecraft magnetic field measurements throughout the spacecraft operations around Saturn and its neighborhood, and was responsible for the discovery of geysers from an ocean below the surface of Saturn's moon Enceladus. Wow, that is so cool.
Yeah.
This discovery changed the entire perspective on the Saturn system and even where life might evolve in the solar system. Wow.
Yeah, crazy stuff. Absolutely mental. A couple of little facts before we get started. This will be one of the final launches of the European Space Agency's Ariane 5 rocket, which is set to be replaced by the Ariane 6 once that rocket has been finished. We might have to do Ariane 5 retirement podcast in the future. So it's launched some pretty cool things. Another fun fact about this mission is that JUICE is going to be the first probe to end up orbiting another planet's moon. Obviously, we've orbited our own moon, but we've never had something orbit another planet's moon. It will end up orbiting Ganymede, which is quite exciting. The Europa Clipper, which is also due for launch next year, is also heading to Jupiter to check out Europa. But like all previous missions, it will be observing by performing a number of flybys. And this is how JUICE will start out too, but it will eventually settle into an orbit. And the height of that orbit will depend on how early into the launch window is able to get away from the Earth. So fingers crossed it will launch today, because if it has enough fuel to get to a low orbit, the data we receive will become even better. Anyway, let's hear from the expert. Here's Professor Dougherty.
Never miss an episode. Make sure you're subscribed on your favourite podcast platform. And don't forget to leave a review. This is Space and Things.
Welcome, Professor Dougherty. Thank you so much for joining us to talk about the JUICE mission. Before we get to that, we'd love to know a little bit about your origin story. We know that you're the head of physics at Imperial College and that you worked on the Cassini mission, but let's go back before that. What got you interested in space? Was it space that got you interested in physics, or physics that got you interested into space?
Wow, that's quite a first question, Dave. Okay, so I was born and brought up in South Africa. I went to an all-girls school in South Africa, which in those days didn't actually teach science.
Wow.
So I didn't do science at school, but I was very good at maths, and I didn't know what I wanted to do after I finished school. And I was really fortunate in that the local university where my dad worked accepted me on a Bachelor of Science degree. So the first couple of years were a bit hard. I didn't know any physics or any chemistry, but I enjoyed what I was doing. So I ended up actually doing a PhD in applied maths. I went to a Max Planck Institute in Germany for a couple of years, where I continued to work more on applied maths themes. And then I came to Imperial College London. And after I'd been here about 3 months, I was asked if I wanted to put a magnetic field model together for Jupiter, because there was a spacecraft called Ulysses that was going to use Jupiter to get up out of the equatorial plane and go around the poles of the sun. And I didn't know what that entailed, but it sounded exciting, so I said yes. And so that's how I became a planetary scientist. But I think I can go back even further in time, actually. My first view of Jupiter and its moons, and also my first view of Saturn and its rings, was through a telescope that my dad built. He ground the mirror of the telescope himself. And I remember my sister and I were so excited because we mixed the concrete for the base of the telescope, which of course was the most important part about it. But that was my first view of Jupiter and Saturn. So whether that had an effect of where I've ended up, I don't know. But it's pretty exciting that I'm doing what I'm doing.
Oh, absolutely.
Excellent. So we know that JUICE is on its way to visit Ganymede, Callisto, and Europa. So what is it about those three particular moons of Jupiter which makes them worthy of having their own mission?
I'll take a step back, if you don't mind, just to set the scene a bit. From my perspective, one of the most important realizations that planetary scientists have come to in the last 20 years is the fact that if you're searching for liquid water, which is what you do if you're looking for places where life might be able to form, we've mainly focused on planets close to the sun. Because if you're looking for liquid water on the surface, you need to be close to the sun or the parent star. And it was following the Galileo flybys of Jupiter's moons back in the late 90s, and then the Cassini-Huygens flybys of Saturn's moons in the 2000s, where we realized that you can find liquid water very far away from the sun, but it's underneath the surface. Right. And in fact, 3 of these moons of Jupiter, the ones that you mentioned, Emily, we're almost certain all 3 of them have got liquid water oceans underneath the surface. So we want to go there and find out more.
So based on those previous probes and studies of these moons, do you have a favorite?
Okay, so I think once we get to Jupiter, Ganymede will become my favorite. But at the moment, Saturn's moon Enceladus is my favorite, because that was the real discovery of the Cassini-Huygens mission.
Yeah.
My instrument saw some strange signatures in the magnetic field that we used to persuade the Cassini project to take us really close on a subsequent flyby. And that's when we realized there was this outgassing of water vapor from the south pole of the moon. So at the moment, Enceladus is my favorite, but I will become fickle once we get to Jupiter.
That's awesome. Yeah, there's a lot there. So you are the principal investigator for the magnetometer. I think I'm saying that right.
You are.
And awesome. Okay, good. Woo. In really simple terms, if possible, what does that bit of equipment do, and how does it work?
Okay, so what the magnetometer does is it measures the magnetic field in the space environment that we're in. And most planets in our solar system, but also the moon Ganymede, have got an internal magnetic field. It's generated in the deep interior. So it's a little bit like if we could see the Earth and we were stepping back and looking at the Earth, if you could see the magnetic field, there would be these field lines which are essentially emanating away from the Earth. Another way to think about it is if you've got a piece of paper, you put iron filings on top of the piece of paper and a bar magnet underneath. Those iron filings will lie along the lines of force of the magnet, and that's essentially the magnetic field lines of the planet. So what my instrument does is it measures the vector field. So it measures the 3 components of the magnetic field. So it gives you the direction, And it also then allows you to work out what the magnitude of the field is. And one of the really cool things about the instrument is by measuring the magnetic field outside, you can get an understanding about what's going on inside.
Obviously, Jupiter has a very big magnetic field itself.
Yes.
Do you have to factor that in when you're looking at one of the moons? Because obviously there's going to be an overlap, isn't there?
Yeah, it's what I lose sleep over, Dave. When I wake up at 2:00 in the morning, that's what I worry about. So, one of the reasons we want to go to Ganymede is, well, from a magnetometer perspective, it's a paradise. It's the only moon in the solar system that's got its own internal dynamo field. We want to try and understand why. But then Ganymede is orbiting around Jupiter, and so it's embedded in the magnetic field of Jupiter. Jupiter has its rotation axis and its magnetic axis have got a 10-degree dipole tilt. And so as the Jupiter is rotating, the magnetic field of Jupiter is wobbling up and down.
Wow.
And so that's changing as it goes past Ganymede. Because Ganymede has got its own internal dynamo field, it essentially forms a cavity in the magnetosphere of Jupiter. So you've got all of that going on. You've got these plasma currents that are flowing. And then on top of that, you've got induction signals from the ocean that we're trying to tease out. And so we have to model everything else first. We have to almost subtract it away from the data and then tease out these small induction signals. And the way I like to describe it is it's like trying to find a needle in a haystack, but the needles are changing shape and color all the time. So that's what I lose sleep about at 2:00 in the morning.
Understandable.
Wow.
Yeah.
That answer really blew my mind. So I believe that the magnetometer is one of 10 instruments on board. What are the others, and are the instruments included to help each other, in concert? Do they work together, or do they have completely different areas of study?
Oh, yes, you're right. There are 10 different instruments on board. I'm probably not going to remember all of their names, so don't let the other PIs know that I've forgotten the names of their instruments, but I can give you an overall picture. So there are instruments that take measurements where they're at. So plasma instrument, energetic particle instrument, the magnetometer is one as well. There are instruments that remotely sense what's going on the surface or have a look at the atmosphere of Jupiter. And then there are instruments that are able to get an understanding about what's going on in the interior. So there's a gravity instrument, there's a laser altimeter that'll fire a laser at the surface and be able to work out how deep the ice crust is.
Oh, wow.
And so for us to do the best job we can, we need to put the data together from all of those instruments. So the way that we'll work is we'll be taking our own data, we'll be analyzing it and putting an idea together about what we're seeing, but then we'll be getting together and putting all the data sets together. And in fact, on board the spacecraft, 2 of the instruments get our data on board the spacecraft. So we share it with them straight away.
Oh,
that's
nice.
the plasma instrument and the radio wave instrument, because they need our data to understand their own. So None of this can be done by ourselves. We've got to work together. And when I say got to, I make it sound as if we're being forced to. It's the best. It's the way to get the best results out, is to work together.
Absolutely. Will there be a camera on JUICE? And if so, will we get images of these moons in better resolution than, say, like the Voyager? Or...
Absolutely, Emily. Yes.
Okay.
There is a plan, I think, for Ganymede, and I'm hoping I'm remembering the details correctly. When we put this proposal together to the European Space Agency back in 2012 to choose JUICE, my recollection is that for the surface of Ganymede, we will get an understanding, a resolution of the surface 50 times better than was obtained from Galileo. And that was sometimes better than what we got from Pioneer and Voyager. So yes, the visible camera will be viewing the surface, but also we'll be looking at it in the infrared as well.
Okay, so one of the things that people are talking about with JUICE and these moons is that they may have life on these moons in some way. What are your own thoughts on whether life might exist on these moons?
So I always like to preface a conversation like this by saying that I prefer not to talk about life. I prefer to talk about the conditions for life to be able to form. Right. So when we made the case to the European Space Agency for JUICE to be chosen, we talked about getting an understanding about potential habitability? So are the ingredients there? So from our understanding of how life evolves on the Earth, you need there to be 4 things. You need there to be liquid water. You need a heat source of some kind. You need organic material. And then you need those first 3 ingredients to be stable enough over a long enough period of time that something can actually happen. And so that's what we want to do with JUICE, is to confirm whether the environment and the ingredients are there for life to be able to form either in the past or maybe now as well.
Okay, so one of our Patreon subscribers, John Wisenhunt, has sent in a question, which is a good follow-up, I think, here. He said, are there plans for a next step after JUICE, like maybe even sampling the ice rather than just observing it? That's already in place, is it?
Well, we know that the next step would be to actually land on the surface of one of these moons and try and get underneath the surface. Probably the prime candidate for that is Europa, because we think the ice crust at Europa is much thinner than it is at Ganymede and Callisto, but that's one of the things we want to try and find out.
Yeah.
And in fact, there were plans by NASA to send a Europa lander. I always thought they were a little premature in the sense that where do you know where to land?
Yeah.
You really have to get an understanding about where the ice crust is thinnest. And so that would be the next step. So not only is ESA's JUICE mission going to 3 of the moons, but NASA's Europa Clipper mission is going to have, I think it's 50 flybys of Europa. And so from that data, we'll get a really good understanding about where the ice crust is thinnest. And then, of course, the next step after that is to send a lander to get underneath the surface.
And now I have a follow-up.
Sure.
Bearing in mind, we're hoping to find whether there are the conditions for life on those moons, and we're potentially going to go and land something on those moons. Do we have to worry about upsetting potentially any ecosystems?
Yes.
When we're planning these kind of things?
Yes. And so, in fact, there is an entire, it's called the Planetary Protection Program.
Right.
If there is even a very small chance of a spacecraft that you send out there, potentially, if it runs out of fuel, crash landing on the surface of a moon where life might have formed or will form in the future, you need to be very careful you don't do that. And so, for example, just going back to the Cassini-Huygens mission, the Huygens probe, the European Space Agency Huygens probe, was put through this planetary protection exercise because it was going to land on the surface of Titan. And so I think effectively what's done is it's pinged with lots of energetic radiation to kill any bugs before it's actually launched. The same would happen for anything that we plan to land on the surface of Europa, for example. And so when mission planners put together a mission profile, they always have in the back of their mind that we can't afford to crash land on this particular moon, so we need to make sure we have enough fuel to be able to move away from it.
Of course, absolutely.
All right. So when will we see results from the JUICE probe?
Well, we will be taking data as we're going out to Jupiter. But one of the things I've learned in outer planetary missions is you need a huge amount of patience. So once we've launched, it's going to take us 7.5 years to get there.
Wow.
I know. It's a very long time. To be able to launch a spacecraft as large as JUICE with enough fuel to be able to do anything useful when we get there, it takes a bit of time. Once we're there, we will have 3 years first orbiting around Jupiter by flying past Europa twice. I always lose track of how often we're going to fly past Callisto, but I think there are at least 20 Callisto flybys. We're also going to be flying past Ganymede, but then the end of the mission is to go into a circular orbit at Ganymede. And for me, one of the biggest difficulties is to try and constrain the excitement of the team and people like you, Emily, who are saying, when are you going to give us results? Because our main aim is to constrain the ocean characteristics at Ganymede. And we're not going to be able to do that until right at the end of the mission. You need to get into orbit to be able to do that.
Okay. Yeah, because I remember Juno, it took a while for it to get there.
Yes.
Yep.
Always does.
Yep, absolutely. Slow and steady wins the race.
Yeah. So that's about 10 years, roughly, by my calculations, before we're going to get any solid results. Does that mean you already have to have the team in place who you know are going to analyze that data, or are the people working on this data people you haven't even met yet? How does it all work? How do you put your team together for a mission that's going to take this long? How does that all work?
The team is in place. So when you propose to build an instrument, you need to propose with an engineering team that is experienced, and people think, oh, those guys know what they're doing.
Right.
But you also need to propose with a science team that has the science expertise. So, you're in competition. And so I got as many of my competitors on board the team as I could so that we would be chosen. It's a really good team. It's a mix of experience and youth. And that's really important, particularly on a mission like JUICE, because, from when we first started thinking about it back in 2007, we're effectively halfway through the mission. We're 15 years through, and in 15 years' time, we'll be getting the last bits of data. So I've got experienced people on the team. I've got young scientists who are now more experienced than they were when we proposed. They will bring on board young postdocs and PhD students. When I give public outreach talks, I look at the kids in the audience and I say to them, you'll be the people analyzing the data. I'll be watching and saying, no, that's not how you do it. But you guys will be the ones analyzing the data.
That's absolutely blown my mind. So how many of these kind of missions does a scientist get in their life then? Do you have multiple running at the same time, or do you have to be completely focused on just one mission?
So I've been involved in 3 different missions. Ulysses, I just came in when I first got into planetary science. Cassini, I became involved just after launch, and so I was involved in the science phase. And during the last 10 years of Cassini, I was beginning to prepare for JUICE and try and get it selected. So you need to be working on multiple things at the same time.
This is blowing my mind. Anyway, one last thing. When you started this planning process, what was the thing you thought you were going to learn from this mission? And are you hopeful that we're going to get a load of surprises as well? It's probably a bit of a silly question.
So for us to be able to match the proposal that we made to ESA back in 2012, saying choose JUICE as the first large mission to go, we will characterize the ocean at Ganymede. We'll work out how deep it is, what its salt content is, because it's that conductivity that will tell us how big the electrical currents are that flow in that ocean. Those electrical currents generate a magnetic field, which is what we're trying to measure. We will also work out, in conjunction with other instruments, how global the ocean is. Is it just focused on one part under the surface, or is it a global ocean? We'll work out how deep the ice crust is and what the interior structure looks like. But the other thing about Ganymede, and I haven't mentioned this before, and that is that we think by understanding the interior of Ganymede, we'll understand a whole new class of planetary body known as a water world. And we think there are lots of other water worlds outside of our solar system and inside of our solar system. So we'll understand a whole new class of body. As far as surprises are concerned, bring it on. With Cassini, we never thought we would show that Enceladus had this liquid water ocean under the surface, this outgassing of water vapor, organic material. And I was talking to an engineering colleague of mine. So Julie Webster was responsible for the Cassini spacecraft in the last 5 or 6 years of the mission. And she said to me, when we were planning for the end of the Cassini mission, she said to me, the difference between you and me is that as an engineer, I want to know exactly what's going to happen. I want to plan for any eventuality. Whereas for you as a scientist, you want to be surprised.
Yeah.
And so I want to be surprised. I don't know what that surprise is yet, but come and talk to me in 10 years' time.
Oh, we absolutely will. Thank you so much for doing this. This has been amazing. I've learned a lot and got a much better understanding of what this mission is now. I don't know about you, Emily.
Yeah, this is really fascinating. This is probably one of my favorite interviews that we've had because it's just blown my mind completely.
Yeah,
anything that shakes up my brain, like wow, is a really awesome interview.
Thank you very much.
Yeah, will you be out for the launch? Is that the plan?
I will. I feel a bit like a pincushion at the moment. I've had to have four different vaccinations to be able to spend 2.5 days in French Guiana. But yeah, be out there, heart in the mouth kind of time.
Absolutely.
It's out of my control.
Yeah.
But, then after launch, there's about a 25-day period that's going to be a little bit scary too, because all the booms are going to be deployed and the solar panels are going to be deployed. The magnetometer instrument will be turned on and commissioned. We'll check to see it's working about 20 days after launch. So we've got some nerve-wracking but exciting times ahead of us.
So by the end of May, hopefully we'll know if everything's going well.
Absolutely.
And then we count down 7 years. Right. Easy. Thank you so much for joining us. We wish you all the best. I hope this goes really well. And we'll definitely be talking to you in 10 years' time, I promise.
Thank you so much.
To find out what guests are coming up in the future and submit your questions, head over to patreon.com/spaceandthings.
All right, that was freaking mind-blowing. Like, my brain is like just expanded. I'm really just blown away. I mean, obviously by everything she said, but I think the thing in my mind that really sticks out the most isn't just the potential of the scientific discovery of a new possible world. For me, it's just the dedication these scientists and engineers have to one single mission. Because, I mean, you got to think that this is about 30 years, at least. I mean, probably more, dedicated to this one space mission. I mean, that's a big commitment. 30 years is a long time. I remember 30 years ago, I was a teenager. So that's kind of a bit of a hike in terms of, time and space. So really, these scientists have such a dedication to what they're doing. And plus, it really emphasizes, I should say, the point that planetary science, it really takes a while to discover these things. And it requires a lot of dedication and a lot of, okay, we got to hang in there for the people who are doing it. Like, you're not going to get immediate gratification if that's what you're looking for in this kind of field of study. You definitely have to wait.
The level of patience.
Yes.
Yeah, the level of patience required is off the chart.
Yeah.
Also, how many of these missions get planned and don't happen?
Yep.
Imagine spending years planning and then it never happening. And,
or it gets canceled, or just something happens where they're like, we're just not going to do it. And it's like, what?
Or budget cuts.
Yeah, exactly. I've read a few reports about missions that were cut. There's a lot of planning, at least 5 years of planning that goes in before it gets canceled. I'm like, imagine you're doing something for 5 years and then it's like one day you wake up and get a phone call like, yo, we're not doing it. Like, what? I mean, I've been through rejection and it sucks, but that must be a different level of like rejection. Like, what?
I can't imagine it. Yeah.
What?
I can't imagine it. Imagine then going for it again.
Yeah.
And 5 years later get rejected for another project. There's got to be people out there that have had multiple missions planned or projects planned that none of them have seen fruition. So the scientific community blows my mind. What was great there about Professor Michele was how easy she made it to understand everything.
Exactly, yeah. Because I'll be real, I'm not a planetary science expert. I'm not Jay Galantine. I love reading about it, but I'm not an expert at it. And she really broke it down in a way that, for me, as a dum-dum about this stuff, I completely was like, okay, that makes sense. That makes sense why you would do it this way as opposed to a different way, and things like that. So, yeah, she's awesome.
Even when we were trying to come up with questions beforehand, I was thinking, am I going to insult her by asking something that easy, or to ask her to try and dumb this down for us? Because I was looking at the documents going, I think I understand what they're trying to do, but it's one of those fine balancing acts we have to do where we have to think about people who may not even have heard of JUICE before listening to this podcast, as well as people who may really understand the planetary science. But I think Professor Michele did a great job there of reaching out to all those people and giving them something. If you would want more from Professor Michele, if you want a little bit more in depth than we perhaps went with her, I would suggest that people listen to the latest episode of the Space Boffins podcast, where she was interviewed with a bit more of the science in mind. You'll hear some of the things that she told us again, but there's definitely extra information. If you want that next level up, I would suggest going over there. But she's just great.
Well, also Juice is an ESA mission, so I think as an American myself, I'm not as familiar with the ESA missions as perhaps people in Europe or England are. So it's good to have somebody explain that. What they're doing, because ESA really, if you dig deep, has an incredible deep space interplanetary exploration heritage. I want to say it starts with Giotto from 1986, the Comet mission, where they basically flew a spacecraft through a comet.
Yeah.
They did, and it survived. I mean, I read about that, and I was like, no, that's a joke. That didn't really happen. I thought it was some bad Bobby adventure that somebody made up. I was like, they didn't do that. Come on. And then I saw the pictures, and I was like, they really did that. They flew a spacecraft through a freaking comet, and it didn't die. It was damaged, but it stayed alive. But that, to me, is incredible, and I think I don't want to underestimate ESA's really incredible deep space heritage. That's all I gotta say. And I think more people need to be aware of it.
It was interesting. I was reading Tim Peake's book, and he spoke about when he went for one of his interviews to be an astronaut, and he obviously flew out to ESA, or got the train out to ESA, whatever it was, the headquarters. And he had some time before he went in, and there was a museum there where they kind of had the ESA greatest hits, and he went around and learned all about ESA's contribution to Cassini and things like that, and as a result, he went into these interview and spoke about these things, and he thinks that's one of the reasons why they picked him, because he had this extra excitement and knowledge about these probes and this exploration, which ESA had been a part of, as you say, for a long time now. So yeah, this is another step on that, and I think it's great that they're doing this. I also think you got to love Juice as a title. I mean, it's just the tastiest probe we've ever had.
Yeah,
as I like to say.
Yeah, it's a nice sort of inviting name. It's not intimidating or anything like that. It's a nice name.
It's accessible.
It's accessible.
For sure.
Yeah.
Okay, the full unedited interview will be up on our Patreon page, patreon.com/space and things.
Dave will put a link to that in the show notes.
So, Emily, what's caught your eye in spaceflight since last week?
It's actually kind of appropriate. It's not about Saturn or Jupiter or any of those moons or anything like that, but it's about one of the other outer solar system planets. This week, the Webb telescope, or in the last week, I should say, ESA Webb telescope returned a new picture of, and let me say this so I don't embarrass myself too badly, Uranus. Yeah.
It's impossible to say without giggling. It's okay.
It's early in the morning here, and I'm trying to say it in a way that's not going to make me crack up or wake up the entire house. So the Webb has revealed a new image of Uranus, which is one of the way outer solar system planets, way out there. And this image is exquisite. I'm sure we'll have it in our show notes. The picture itself, it's astonishingly high resolution, given that the Webb is pretty far away from that target, but it's a really awesome photo. You can see some of there's some very faint rings around the planet. I'm trying to say this without embarrassing myself. There's some very faint looking rings around it. It's just really an exquisite photo. There's not many pictures of that planet because not many things have imaged it. I think the Voyager spacecraft imaged it,
which remains currently the only craft to have visited it as well, isn't it? Actually,
you
did
are
a
correct.
flyby. Voyager 2 was it? I think
so. You are correct. It's the only spacecraft that's imaged it. There's never been another spacecraft sent around that target, and I wish they'd send another one because that would be really cool. I wish they would have like a Cassini class type mission that would go around like Uranus or Neptune or something like that, because really there's not many pictures of those, or not many great pictures of those planets, because they're so far out, and there's just not very much known about those other than some basics as to what they look like. But that would be really cool. So that's what caught my eye this week. really cool picture by the Webb telescope. We're less than a year into what Webb has revealed to us, and it's really just really incredible. And we're gonna see a heck of a lot more over the spacecraft's lifetime. So that's really what caught my eye this week. Just a gorgeous picture of a little explored outer solar system planet that I don't want to embarrass myself by saying its name.
It's crazy, isn't it? I had this one written down as well. I wondered whether you'd bring it up. It's such a beautiful image. It's crazy how Uranus and Neptune we just haven't seen much of, have we?
No, not at all. I mean, yeah, we've probably seen more of Pluto. I mean, really,
well,
if you think about it, we've seen more of Pluto, and Pluto is very far out there.
Yeah, we do. We have higher resolution images of Pluto thanks to New Horizons. It could be that's not even a planet.
Yeah, or the Kuiper Belt objects, which are, not even planets or anything. They're KBOs. But yeah, it would be really cool. Like I said, if something like this was devised, it would be really cool. It would probably take a decade or more, knowing what we know about how much it takes to develop planetary missions. But I would love it if they had like a program just dedicated to exploring one or both of those planets. That would be really cool.
Yeah, completely agree. And you think how much we've learned from the Galileo mission to Jupiter and Cassini to Saturn, how much we learned from those missions about Saturn and Jupiter, and the wonderful images we have of those huge planets with all those moons they have, and Neptune and Uranus have that too. So yeah, I would be in favor of that as well. Although, Emily, one of the other things that caught my eye this week was the delay to the Veritas mission for Venus. I don't know if you've seen that. We spoke about the fact that there was lots of missions planned for Venus all happening at once, and it all kind of depended on this first NASA mission, the Veritas mission, which was going to map the surface in such high resolution, higher than we've ever had before. I think higher than the Magellan that went before was I think the name of the spacecraft that went before.
Yeah, that is correct.
And the others were going to go and use that data to do what they were planning on doing. And annoyingly, it looks like that's all being thrown out because of budget constraints, and I think it's because of the Psyche mission being delayed, which is causing problems for the Jet Propulsion Laboratory, and therefore this has had to be delayed, and therefore the budget's kind of been put on hold. It looks like we're not going to get the Venus stuff that we want either. I know that the Planetary Society is lobbying hard of Congress to try and make sure some extra funds are found from somewhere to try and make this happen, but I think it's going to be a tall order asking for more funds for spaceflight. We're already at the biggest budget we've got for NASA in a long time from the US government.
Yeah.
So, but it would be a shame if we lose another planetary mission when it looked like we were going to have this golden era of Venus coming up in the next 5 to 10 years as well, which would have been amazing.
That's a disappointment. There's a petition, I need to sign it because, I was hoping to see more Venus exploration just because there's not really many spacecraft that have observed it. It would be really cool to get better images of Venus.
And it's the closest planet to us, right?
Yeah, and it's just so mysterious. Like, I see it in the night sky, and I'm like, man, it's enshrouded in clouds. It's got that weird retrograde orbit. Nobody's sure why, really. And I'm like, it would be really cool to discover more about it. It's kind of like Earth's evil twin in a way. It's very inhospitable, we'll just put it that way. It's very hot, lots of pressure. They've never really successfully put a lander on it for more than like 50-something minutes. So it would be really cool to find out more about it. So that's kind of disappointing to me because I remember when we did that episode about when they found, or apparently found, phosphine in the atmosphere and how, they were sort of planning to do all these new missions to Venus. And I was like, man, that's really exciting because there's just so little known about that planet, really. I think there have been some observations of the planet made from Earth from the Arecibo telescope, but that telescope's not around anymore. So,
two other things that have caught my eye. Have you seen this Dawn Aerospace space plane? It was been tested out in New Zealand.
I have not.
Well, it's not the first time they've done a test flight. It hasn't gone to space yet, but they've finally put the jet engines on it, and they worked. What? So essentially, and this will fly from a commercial airport in New Zealand as well, which is pretty cool.
That's cool.
and this will be able to do 2 flights to space and back again a day.
What?
That's what they're saying is going to happen. So this is Dawn Aerospace, and I'm going to try and find out more. I'll put a link to an article in the show notes, as with all these stories we're talking about. But this looks cool, and it's going to be able to do. I don't think it's going to be crew rated. It's going to be for small science payloads. I think.
Okay.
I think that's the idea. I
Okay.
think it's an automated service. But yeah, this is a cool thing. We love space planes. After all our talk of shuttles over the last couple of weeks, it's nice to see that there could be another operational space plane of some description, which is very cool.
That would be really cool. That would be really awesome. I kind of have a soft spot in my heart for space planes, so that would be really neat.
Absolutely. And while we're talking about new spacecraft, it looks like we might finally see the first orbital launch attempt of the Starship this month. There's chat that's going to happen sometime around April 20th, perhaps.
Okay. I'm nervous.
Yep, so that's the new SpaceX heavy lifting vehicle that will launch from Boca Chica. They're going to try, it's a 2-stage thing. The first stage, the heavy part of the rocket, they call it the heavy booster. It's got 33 engines on it. And then they will launch for that. Within 3 minutes, that will burn out, and then they will separate, and that top stage, which is called Starship, will go into orbit, hopefully, and they're going to try and land vertically the booster somewhere close to Boca Chica, a few miles away, and the Starship apparently is going to, after doing an orbit, is going to land in the ocean, controlled landing in the ocean, apparently, somewhere near Hawaii, if it goes well, which obviously is a big ask, I think. We recently had that first launch from
Relativity Space to the Terran 1.
Yes, we recently had that, and that was the first launch of a brand new rocket. And it was an orbital attempt, and it made it past max Q. And everyone said, for a new rocket, that is incredible.
Yeah.
So I think we have to use the same parameters for this rocket. If they manage to get it past max Q, then they've done incredibly well. If they get it into orbit, that's next level. If they can complete every mission objective, I mean, that's off the chart. And you should never count SpaceX out for these things. They've got experience of being able to do things, and good experience too. But I think this is a tall ask, and I don't think they're expecting to get it all correct. But that's what they're planning on doing, and hopefully it at least gets far enough from the pad that it doesn't damage anything if it goes wrong.
Yeah, because I was about to say that's enormous. I mean, I've seen pictures of it, and it's just, it's really just staggeringly huge. And I'm like, man, like you said, I hope it's far away. If something does happen, which I hope doesn't happen, I'd like, ideally, I'd like it to go really well, because that would be awesome. Yeah. But if for some reason, it doesn't, I hope it's further out from the pad so it doesn't affect any of the infrastructure around there, because that would kind of suck, so
so obviously this has been in development for a long time now, and there was talk that this was going to happen for ages, and they've been waiting for permits and all that kind of stuff to make sure this was going to happen. Essentially, it will be the most powerful rocket ever launched if it's successful. Even more powerful, I believe, than Space Launch System, which Artemis is being launched on. However, we're still a long way from this being an operational rocket, which now Artemis has been proved to be. We're a long way from that. So it's exciting that it's potentially having its first test launch, and that's how they do things. Whereas Artemis, as Space Launch System, was all tested on the ground before given an operational go. SpaceX do things differently. They do this method of testing where they do it as they go along, and if it goes wrong, they learn from those lessons. It's how NASA used to operate back in the 60s, but it's different. You don't expect it to go well, but it will be a show. You know that from SpaceX. It will be a show, and if you see someone tweeting the live stream, definitely turn it on and keep your eyes peeled for it.
Well, I think there's also a difference, because the SLS had shuttle heritage, and some of it had been flown already, so I think they kind of had a little bit of a clue as to, okay, how is this thing going to perform. I'm honestly surprised SLS went as well as it did on the first try. I mean, that's almost unheard of. So just amazing. I didn't want it to go bad by any stretch. I don't want to make it sound like, but I was very like, wow, that performance, considering it was the first time they did it, was just off the charts. So it's not that I underestimate SpaceX by any stretch of the imagination, but what they're trying to do is kind of completely brand new. So I don't expect it'll go perfectly, and that's fine. So
yeah, I don't think they're expecting it to either. A lot of the public chat we're seeing from people who work there is quite reserved, and I think that's fine. Obviously, to have all the objectives, you need to have all the objectives of what you're trying to do. You need to have them written down. But I don't think they truly expect it to all go swimmingly perfectly. If it does, everyone's a winner. If it doesn't, there's still a lot that they're hoping to learn from every stage that goes successful. So the further it goes into the mission, the better. But you know they're going to learn from every single step of this. Even if it's just fueling it up and getting it ready, you know, the same way we learned from about the Space Launch System from all those wet launch tests last year, or wet dress rehearsals as they were called. You know, all that is a learning experience for the engineers and the team back on the ground. So a lot to learn with something that's brand new and completely unknown compared to, as you said, other things which may have had some heritage.
Yep, absolutely. Yeah, it'll be exciting to watch. So we'll see. Fingers crossed.
Could be a good month.
Fingers crossed.
Could be a good month.
Past to present, Sputnik to Starship. This is Space and Things.
Okay, that's all we're giving you this week. I hope there was enough to keep you satisfied, and hopefully come back next week. We've got big plans for the next few months, so hopefully those episodes will interest you as they come out. If you've enjoyed this episode, please consider sharing it with your friends or leaving us a review on your podcast app if it allows.
Thank you to Jen Jones, our Patreon subscriber who has provided this week's stings, and thanks to Kevin Jennings for signing up this week. He's told us he's signing up just because he wants to do the stings. So we look forward to hearing what you send us, Kevin. And
absolutely.
Thank you to all who continue to support us in making this podcast. But don't forget, in space, no one can hear you mean.
You've been listening to the Space and Things podcast.